All right. We once again will be challenged to create two NGINX servers in a bastion host. And we will be tasked with doing this where one NGINX server is a reverse proxy that forwards traffic to another NGINX server that displays some sort of custom HTML page. But we're going to do it with a click of a button or one command in our terminal, all right, instead of setting everything up manually, okay? And we're going to use Terraform to do it, all right? How does Terraform work? Let's go ahead and go to the documentation and take a look. So Terraform is made by HashiCorp, where I happen to work, which is pretty cool. And you can automate infrastructure on any cloud with Terraform, okay? So we will need to first download Terraform and then we'll need to use it. So let's go ahead and get started with downloading Terraform. So I have a Mac, so I'm going to go ahead and follow this. If you have any other type of system, such as a Windows or Linux, go ahead and follow the way that it tells you to. I'm going to bring up my Terraform. You can see that I went ahead and installed some of the things that we're about to install because I want to make sure I'm starting right from the beginning. I'm actually going to open up a new window just to start from the very beginning. All right. So I'm going to say brew tap HashiCorp/tap. All right. And then I'm going to let it run. It's asking me for my keychain password, which I'm hoping is just my login password. All right, cool. And I'm going to say brew install HashiCorp/tap/Terraform. And then I'm going to go ahead and now I'm going to have Terraform. Gonna wait for it to install. Perfect. All right, so now I should be able to say like Terraform version, and I have Terraform installed. Yay. All right. So the next thing that I want to do is I'm going to go ahead and I am going to open up a VS Code. This is the VS Code for my website. I'm going to open up a new window and I'm going to add it here. All right. And then I'm going to go ahead and I'm going to start a new file. You can just do a text file and then, nope. I'm going to actually, let's go ahead. I'm going to pull this up so you don't look at all my files, but I am going to create a new folder. I'm going to call my folder Terraform challenge, like I'm going to call it deploy in public. So DIP Terraform 1. Right now I'm going to go ahead and open DIP Terraform 1 and open it up. So now we have our folder. You can see that, and I will note that I did already write a Terraform module for this. I'm not using it right now. I'm not like going to watch it in code. I'm going to kind of do it from scratch, but I did want to make sure we could get all the way through the challenge. So if it takes you a little bit longer than it's taking me, that's okay. I literally just did this challenge, not recorded, but I'm going to still try to walk through everything and look up the docs as I go. All right. So now let's go ahead and create a file. And I'm going to go over to the kind of getting started. So let's go to next steps, getting started AWS. You can see that there's some tutorials there. And these tutorials are actually pretty helpful. You can see like you'll learn what infrastructure as code is, you'll learn how to install, and then you'll learn how to build. So here's creating an EC2 instance under the AWS free tier. So that's actually similar to what we want to do. And you can see there's a 3-minute and 55-second video where they go over it. All right. And this is helpful too, because now you can see that we have some prerequisites. So we need an AWS account and associated credentials to let us create resources. and we need the AWS CLI installed. So what I'm going to do is I'm going to go ahead and I'm going to type in AWS CLI, and I'm going to go and look for how to install it. Okay, AWS CLI, what does that mean? So that means that we are going to install a CLI that we can use to communicate with AWS from our terminal. And that way we can kind of log into an account from our terminal and use it. All right, so let's open up the Mac OS because I have a Mac. And I'm curious if I can do brew install AWS CLI. Okay, it looks like I can, so I'm going to go ahead and copy it. Oops, don't need Zoom open. And I'm going to paste it in. While it's doing that, I'm going to go back and read this Medium article about installing AWS CLI using Homebrew to get a little bit of context. All right, so brew update, brew install AWS CLI, and then we're going to check the AWS version. And then we need to configure AWS, which will include our AWS access key and our secret access key, default region, and output format. Okay, so when I run this command, it's going to ask me for all of these things. All right, let's open our terminal again. It's still creating it. So what we need to do is we need to go find our AWS access key and secret access key. All right, we already know our default region, which is going to be US East 1. Okay. An output format. I'm curious what we'll do for output format. Probably just whatever the default is, to be honest. All right, so the way that you can get your secret access keys is by clicking on your role in the top corner, and then you should see security credentials when you go here. But we don't see that. That's because we used the IAM Identity Center to create our user, and we checked the box that when we created it, if you followed my video, that we wanted to use console access. All right. Console access means I'm going to log into the AWS console. All right. And I'm going to do everything manually. But now we don't just want console access. We want to be able to actually take our credentials and use a AWS CLI with those credentials and then use Terraform. Okay. So we're going to need to create a new role for this, or a new user for this. Okay. So right now I have no users in the IAM center, or this is not the other identity center. All right. So we're going to create username, and then we're going to put in a username. So I'm going to say coding with Callie, and then dash Callie Stroska. Provide user access. So you can see the check here that this is optional. If you're providing console access to a person, it's best practice to manage their access in IAM Identity Center. So this is going to create the user in the Identity Center, which is what's recommended, and that's what's going to do the create access. But I want to create an IAM user so that way I can enable programmatic access through access keys. Okay, so I want the IAM user. I'm going to go ahead and do a custom password. No, I'll do an auto-generated password, and then users must create a new password at the next sign in. That's fine. All right, and then I'm going to click next. All right, so now I'm going to add users to a group. Copy permissions or attach policies directly. And I'm going to attach a policy directly, and I'm going to attach the administrator access here. And then I'm going to go ahead and click next. You can also see that there's already one attached entity, which is going to be our administrator access, which is what we're on right now. All right, so you can see that my permissions is going to be administrator access, and IAM user change password. So I'm creating a user. This time I'm creating an IAM user, and the reason why I'm doing that is so I can access AWS programmatically and not just in the console. So I'm going to click create user, and you can see that I have my username, I have my console signing URL, and my console password. All right. Now I'm going to pull this to my other monitor because I'm dealing with passwords now. But what I'm doing is I'm copying the console sign-in URL and I'm pasting it into the browser. And I'll show you this in a second once I have this all figured out. And then I'm going to put in my username. It's asking for the IAM username, which is coding with Callie, CWC dash Callie Stosecup. All right. Then it's asking me for my password. Which is interesting. I'm going to sign. In doing that, I just went to sign in and it kicked me out. So now I'm going to have to get back in to do this. I am going to pause here and I will resume filming once I get back into my account and set my password, and then I'll show you what's going on. All right. I don't know how, but somehow when I pulled it to another tab, it logged me out of AWS and I hadn't reset the password yet. So I had no idea what it was. So I had to go in and reset my password. But anyway, so what you're going to do is you're going to go to AWS to sign in. And instead of root user, we can finally use IAM user. And instead of that, we're going to put in our account number, which is going to be, I'm copying it from another tag or another tab in another window if you can't tell. And then we're going to click next. And then here we're going to put in our IAM username, which mine is going to be coding with Callie Stosecup. And then I'm going to create login. And now you can see that I'm logged in under my username. And now you can see that I have security credentials, which is very exciting. All right, so I'm going to next, now that I have AWS CLI installed, I'm going to type in AWS CLI configure, which did not work. So let's do AWS CLI dash version. All right, let's go back to over here. Oh, it's just AWS. Silly me. AWS dash version. All right, and we got a version, so I think that means we're good in terms of installing, and then we can go to AWS configure. And now it's going to ask for our access key ID. All right, so this is how you're going to find your access key ID. So you're going to go over here and you're going to click on security credentials, and then let me go ahead and pull this once again to another tab so I don't show any credentials I'm not supposed to. All right, and then you're going to see when you go to this page, you're going to see if you scroll down, okay, you don't see anything. So if you scroll down, you're going to see access key, and then you're going to click on create access key. And then here it's going to tell you what you want. So I want to be able to use the command line interface. All right, so I'm going to go ahead and do that. And I'm going to say, I understand the above recommended. Oh, interesting. So it looks like I could also have added this to my IAM Identity Center users. So if anyone wants to try that, go ahead and do it and then let me know. And it looks like there's another browser-based CLI. I don't really want to use that. So I'm going to go ahead and say, I understand, and click next. All right, then you can go ahead and set a description tag. I'm now going to actually hide my screen because I don't know what's going to pop up on the next one. And I'm going to set my description tag before I do that as coding with Callie, deploy in public, and create access key. So now on my AWS CLI, it's asking for the access key ID, and it's right in front of me in my face. So I'm going to go ahead and paste that in and click enter. Now it's asking for my AWS secret access key. And once I created the access key, it's like the only two things on the page. So don't be too super concerned if you can't see what I'm doing. I just don't want to show my passwords. Now it's asking me for my default region name. So I'm going to do US-East-1. And then default output format. I'm going to go back to this and I'm going to see, it doesn't really seem like it says anything. So let's go ahead and over here, we're going to say AWS CLI, what to put for default output format. And we see that we have this. So it looks like there's an output option in the config file. All right, I'm going to leave it. It looks like, I think output is going to be, and you know what? I'm just going to send it and I'm going to say JSON. Maybe I'll regret it. Maybe I won't. We'll see. Okay. But it looks like it's pretty easy to reconfigure it if you do. All right. So now I am all set to use AWS. All right. Now that we're able to access AWS programmatically with the CLI, we are also all set up in terms of downloading and installing Terraform. We can go ahead and get started and write some Terraform. All right. So the first thing that we're going to do is we already have our folder. That's what mkdir means, is make directory. We already have one. We're using DIP Terraform 1. All right. CD means change directory, and they're going into it. We already enter it. And then touch is making a new file. So we're going to go ahead and do that. Touch main.tf, which is a Terraform file. So if I open up my files over here, you can see I have main.tf. You can see it has a little Terraform logo. All right. The next thing that we need to do is we need to have our AWS provider in here. Okay. So here, what they're doing, the way Terraform works, okay, is this is part of it is going to set up Terraform and set up that AWS is going to be the provider that we're going to be using in our Terraform plans. All right. And it's going to set up what region we want to communicate with for AWS. So I'm just going to paste it in as we have it, and then I'm going to edit. So we're using US East 1, at least that's what I'm using. So I'm going to make this US East 1, and the rest of it, I feel like I'm going to say it's okay. The next part of this block that they have here is that they have resource, and what this is doing is it's telling Terraform, all right, please create an AWS instance. All right, that's the word phrase that we would use for an EC2 instance. And then here's what they're naming that Terraform resource app server. All right, they're using this AMI. The instance type is going to be T2 micro, and the tags that are going to be associated with will have the name, would be the key of the tag, and then example app server instance will be the value of the tag. Okay. So they're going to do that. We don't want to start out by creating an instance, but just so I can show you how Terraform works, we'll go ahead and copy this over. All right. So let's go back to sorry. Also, please note in the last video, you can only retrieve your security access keys from AWS once. So if you close out before using them or setting them up or saving them in a secure way, then you will not be able to access them later. Okay. So I actually messed up in right after my last video. I was like, oh crap, I need to export these variables, which is what you'll see here. I did that in the terminal right before I got started, and I went to do my secret access key and I was like, ah, crap, I closed the page already. So all you have to do in that situation is delete the key that you created and create a new access key, and then just reconfigure your AWS CLI to use it, which is pretty simple. You just do AWS configure, and then it'll walk you through the same steps again. All right. But if you have any questions, go ahead and use the AWS CLI resource that I'm linking into this challenge, or reach out over Slack. All right. So now that we have the AWS instance here, let's go keep on keeping on and see what we have. All right. So you can see that it's going to explain it to us. All right. So the Terraform block all right, here contains Terraform settings, including the required providers that you will use to provision your infrastructure. So I'm using AWS to provision an AWS instance or an EC2 instance. All right. So Terraform is then going to install this provider from the Terraform registry. All right. And that is going to be defined here under the source. Okay. The provider block specifies our provider. So we're saying that we are going to require AWS. And now here we're saying, all right, our provider is AWS. You can see that you can use multiple provider blocks. So if you need, let's say you're creating a like secret password or something like that, and then you want to store that in AWS secret service. All right, you might want to create a random number. So I'm pretty sure, let's look, Terraform random provider. So there's a random provider that you could use to create a random number, okay? And other things, for example. So see, here's a good example. So here they're creating a random ID, and then they're going to add, they're going to use that random ID here. If I'm looking super quickly at the docs. But more of the story is you can have multiple different providers, like Docker's a provider. You can do a lot of stuff with Terraform. All right. So the next thing that you want to do is you want to initialize the directory. So the way we do that is we go ahead and we say Terraform init. But what's cool about Terraform, before I click that, I'm going to say Terraform apply. Terraform apply is the command that you use anytime you want to like actually provision the resources that you just put in that main.tf file, okay? And you can see that it's going to yell at us saying like, hey, we don't have a dependency lock file. Please use Terraform init. So Terraform has really great error messages. So if you get an error message in Terraform, it's usually going to tell you what you need to do, and then you can just do it. You can also like then look up the error. So here it's going ahead and it's initializing my provider plugins, and it says that Terraform's been successfully initialized. All right, you can then see here that we have this Terraform folder with the providers in it, and then we have this Terraform lock file here. All right, and that is what the initialization command did. So the next thing that we want to do, if we scroll down, oh, apparently we can use Terraform format. Let's see if Terraform format does anything for me. No, but I also have the, oh, that's another good thing. So I do, where's my extensions? I do have the Terraform extension. So installed, so you can see that it does syntax highlighting and auto completion for Terraform. It's super handy. So that's likely why I don't need a format with the Terraform format command, because I already have my VS Code doing it for me. You can also use Terraform validate to validate whether or not your configuration works. And we have success. The configuration is valid. So let's see if I like got rid of this. It's already going to yell at me from my extension, but you can see it's also going to tell me what's going on. All right, so now we want to do our creating the infrastructure. So there's two commands that are associated with creating the infrastructure. The first one is Terraform plan. So like the command states, we're just going to be planning out what is going to be happening, but we're not going to do anything with it. So when I create this instance resource, you can see that this is what's happening underneath the hood, okay? And it's just saying that it's going to add one resource, it's not going to change anything, and it's not going to destroy anything, okay? So if we like it, then you can go ahead and see it says, if you like this, go ahead and run Terraform apply. So let's go ahead and try that. I am lazy sometimes, and I don't always do Terraform apply, because if you can see, you're getting the same output before, and then it's going to ask you to confirm with Terraform apply. All right, so again, Terraform has great error messages. So you can see here, creating EC2 instance, invalid AMI ID not found. All right, so we would go up and we would look, and the AMI ID is right here, and it's saying it's not found. So what I'm going to go ahead and do is I'm going to go to my console. I'm going to pull this down, and I'm going to go to EC2, and I'm just going to find the AMI that I want to use that I used manually. I'm just going to go ahead and find it here. So you can see the AMI is going to be right here, this guy. Let me see if I can try to pull that off. Oh, here it is. Okay. So I can go ahead and just copy this, and then I can place it in here and save it. All right. So I'm going to click Terraform apply again, and then I'm going to click yes, and hopefully it works. So now you can see that it's creating my AWS instance. The resource is named app server. And when I say the resource is named app server, I mean within my Terraform, it's named app server. It's not actually going to pop up named app server. It's going to pop up named example app server instance. So it's still creating. So let's go back to my EC2. Let's go over to instances. Let's take away running, and you can see that this is in a pending state. What's cool about Terraform is it's going to stay loading until it creates the resource and it's in a running state. So now that we're in a running state, you can see that it says apply complete, resources 1 added, 0 changed, 0 destroyed. All right, let's open this up and let's take a look. All right, so we have, see, our name example app server instance. That's what happens when you add a tag for name, by the way. And then you can see that we have a public IP address, but we didn't set that, okay? We just did like the initial set up an EC2 instance, okay? And as we learned in our last challenge, we want to be much more specific in what we're doing and make sure we have all the right settings, okay? You can also see that when we go to the networking side of things that we just have this random VPC ID. If we go ahead and click into it, we'll see that it's just using, we only have one VPC and it's just using the default one. All right, so we can actually use this EC2 instance. It's not going to work how we want it to work, but that's okay because we learned a little bit about Terraform in the process. All right, so you can see, yep, it worked as nice. Okay. Oh, okay. If you want to see what like the state of your AWS resources are, you can do Terraform show. And then it's going to show you everything about the resources that you provisioned. So this can be helpful if you're trying to figure out like what setting you picked. It's like basically a way of looking at your resource from the terminal instead of the console. All right. Okay, you can also use this Terraform state list. I'm going to just copy that so I don't have to type it. And that's going to just give you like the name, like the specific resources, what you have. Okay. Um, so here, then you can see that we're going to have some next cases. We're not going to follow Terraform documentation the whole time because we already kind of have an architecture for what we're looking for. So we're going to follow that diagram instead. All right, so now what do you want to do next? What's great about Terraform is not only can you apply, but you can destroy. So it probably took you 5-10 minutes of searching through your AWS console after challenge 1 to delete all of the resources that you created. You might have felt a little bit stressed, like, oh my gosh, are there still resources out there? Did I miss something? Am I getting charged? What's great about provisioning your infrastructure with Terraform is that you can just go ahead and write Terraform destroy here. It's going to ask you to confirm, and it's going to show you exactly, see it's refreshing states. It's going to get everything, and then it's saying that we're going to destroy one resource. I can click yes, please destroy, and then it's going to start destroying it. So if I go to my you can see we have 0 instances running, and you can see that we have an instance that's being shut down. And then eventually, after it shuts down, it's going to go to terminated. All right, which again, it's not going to do this until it's actually terminated. It's going to still show you every 10 seconds an update of what's going on with that resource's status. Okay. So this is a very, very simple introduction to Terraform. I am going to kind of leave it here because you can see that it's destroying. I'll just, oh, there we go. Destroy complete one resource, and you can see now it's terminated. All right. So this was Terraform basics. In the next video, we're actually going to start provisioning the resources that we need for this challenge. All right, see you in the next one. All right, so now that we kind of understand a little bit what Terraform does, we're going to get rid of this resource here because we're not ready to create an instance yet. Just like when we deployed manually, we want to step by step go through things. Now, the goal is to eventually have all of our infrastructure planned out so that way with the click of a Terraform apply, we have everything ready to go. And then with a Terraform destroy, everything's torn down and we don't have to spend any money on AWS, right? But we're going to do this through an iterative approach, okay? Let me see if I can find my architecture piece. Let's see. Was it here? I can't remember what software I used at this point. No, it was not. All right, but in general, the first thing that we need to do is we need to set up a VPC. So that's what we're going to do. But we're not going to do it in the console anymore. We're going to do it with Terraform. All right. So here is the VPC console page here. You can see we have the default VPC and subnets and default route table. Internet gateway. Is this a default or did I forget to delete one? All right, I think this is just the default. All right, so let's go ahead and go back to Terraform, and then I am just going to search for what I need in the doc. So I'm going to search for VPC, and let's go to documentation. It's not what I want. So I'm going to say Terraform VPC. All right, and here we go. We are going to the Terraform registry, which is going to give us all of our example for what we want to do. And we can see that not only do you have just the simplest way that you can create a VPC, you also then have more like intricate ways of using this, okay? So we're gonna always start simple and then iterate from there. So here we are just going to be creating a VPC and then we're gonna include what the CIDR block will be. All right, I wanna make sure I name my VPC, so I'm gonna copy this resource here and then edit it as I want. So VPC, I don't wanna call it main, because I guess we can just call it main because we're going to use the tag here to actually name it within the console. So I'm going to call it coding with Callie VPC. All right. For my CIDR block, I'm going to go change this because we don't need like a lot of IP addresses. So we're just going to use the same CIDR block that we used the last one, 10.0.0.24. All right. So now let's go ahead and see how we did. I'm going to write Terraform plan because I'm feeling like doing things the right way. Look through it. We're creating a VPC. All right, here's our CIDR block. All right, so then let's go ahead and we're going to say Terraform apply. Now, while this is applying, I will note, I'm going to say, yes, I want it, that there is like, we are going to do like bare bones Terraform right now. We are just going to have a main TF and we're just going to get everything we want up and running. But there's a lot you can do with Terraform and there's a lot more structure that goes into it. And so like as you go through, you're going to want to look into like some Terraform architecture, and we're probably going to get somewhat there in this workshop, but this isn't a specific Terraform workshop. So just note there's better ways of doing what we're doing. This is just the way I think it makes the most sense to start. Okay, so now let's go ahead and check our VPCs. And it says that we want to have one added, but you can see we have a filter here. So let's refresh again. And oh, look, our VPC is up. How exciting. All right. And we just did that with code. All right. So now that we're here, let's go ahead and do our subnets next. All right. So I am going to go ahead and I'm going to go to search all resources. I'm going to look for subnet. Here's the Amazon official resource for a subnet. All right. So we're going to go here and you can see that in our basic usage, we're going to have the VPC that we're associating, our subnet's going to go into, and then a CIDR block that's going to be associated with it and the tags. Okay. So I'm going to copy this. Now remember that in our subnet, we're going to have two subnets. So we don't want all of the IP addresses from the CIDR block. So I'm going to return to my handy dandy subnet CIDR block resource where I'm going to change this. Oh, it looks like they did a different set of IP addresses. You can see it says 10.0.1.024, but this is not necessarily corresponding with the CIDR block that we're using, so we're still going to get rid of it. CIDR blocks and IP addresses are all things that look into more on your free time, so you really understand what you are doing. All right, and then for our subnet, we're going to name this coding with Kali public. All right, yes, let's call it public subnet. All right, then I'm going to just copy this. Let's change this from main to public subnet. And I'm going to copy this whole resource because I'm going to do the same thing, but now for our private subnet. All right. And then instead of that, I'm going to copy this CIDR block, which is going to represent the other half of the IP addresses. And then instead of having the name tag value be CWC public subnet, I'm going to rename it as private subnet. All right, so once again, when we go ahead and click Terraform apply, it's going to, or we'll do plan first. It's going to tell us what it plans to do. So what is it doing? It's going and looking at the AWS resources that we already have, and it's comparing what we want, which is these three resources, to what we already have. Okay, so you can see that it's only planning to add 2 resources. But if you look in our code, we have 1, 2, 3 resources. The reason for that is because it's comparing what you have to what you need. We already have our VPC, all right? So it doesn't need to create a new one. So when you're using this, you can code in the iterative way where you add here, you edit there, because it's going to then when you hit apply, it's going to automatically change anything that's different, all right? So let's do like a little test here. All right, and I am going to change this from CWC VPC. I'm just going to do -test. Okay. Then I'm going to go ahead and Terraform apply again, and I'm going to see what's going on. Okay. Here now you can see that we have 2 resources we are going to add, and we're going to have 1 resource that we're going to change. All right. So you see this little yellow tilde squiggly line, and that means that it's going to update it in place. Okay. So it's going to use, what does update in place mean? Update in place means that it's going to use the exact same VPC, but it's going to just change the tag. It's going to change the tag from VPC to VPC test. All right. Now, I don't actually want to do that, so I'm going to go ahead and get rid of that. All right. And then I'm going to say Terraform plan again. All right. Now you can see we have 2 to add, 0 to change, 0 to destroy. I accept. So I'm going to say Terraform apply. All right. So where is it getting the state from? So do you see, I'm going to go ahead and click yes, so I can create that while we're doing this. But if we scroll up, you can see that it says AWS VPC main refreshing state. So what it's doing is it's checking our actual VPC and we're seeing if it matches the state that we want it in. Where is that state coming from? It's coming from this file here, okay? This is our Terraform TF state file, and that's going to say everything that it's going to keep track of the state of our AWS resources, and that way, that is how we can have Terraform look at what's desired versus what we have and change the difference, okay? In a production setting / in a team environment, when you're using Terraform, you aren't going to have Terraform locally keep track of your state, because what if you have multiple developers all working on the same Terraform repo, right? If all of us are locally keeping track of our state, we're going to be overwriting each other's changes. So typically you would keep track of your state. And when I say typically, I've only worked at 2 places. I'm not actually sure exactly where HashiCorp keeps track of their state, but at Moody's, we kept track of our Terraform state in an S3 bucket. All right. So I don't know why I'm saying typically. I'm not an expert in all different companies, but you wouldn't want to keep it locally. But if you're the only one working on the project, keeping it locally is fine for now. Okay, but that would be another area of like, ooh, wow, I'm really into this. What's another thing that I could do to challenge myself? And that would be trying to set up S3 to keep track of your Terraform state. All right, so now you can see that we have 2 resources added. So if I'm going to just make my window bigger here. If I go and look at my subnets, and refresh my page, you can see that now I have a private subnet and a public subnet. All right, so we have our VPC and we have our subnets. We still have lots to do, but we are slowly making progress. And you can see that Terraform is not that crazy. It's kind of actually as easy to create something with Terraform and like find the code for it as it is to manually read the AWS docs and figure out what settings you want. All right. But I'm glad that we went through it manually first because now you understand exactly what you're doing with the code. See you in the next video. All right. So after every single like session of work that you're doing, so last night I actually recorded the last video and then I went to bed. Okay, so before I went to bed, I went ahead and I destroyed my resources because why would you pay for resources overnight? Now, I will note that VPCs and subnets are not paid resources, so I didn't need to do that, but you get the point. Terraform apply, then when you're done, Terraform destroy. Obviously, if you're actually deploying the application that you're going to like then use, you're not going to destroy, but for this workshop, Terraform destroy is going to be your best friend. All right, so now that I don't have any subnets, I'm going to need to Terraform apply to get my current configuration back up and running. I'll go ahead and say yes, and then we will get to creating. All right, so if I go to my VPC now, I can see that I can filter by VPC and I have my coding with Kali VPC. And if I go to my subnets, you can see that I have my coding with Kali public and private subnet. All right, so that is pretty cool. I'm going to reload the page because I think it's still hung up on, the arrows, it was still hung up on the other one. All right, so the next thing is, as we learned in the last challenge, your public subnet and your private subnet, the only thing you did, right, if we look at the Terraform code, the only thing that we did was say, right, it's a public, it's a private. But we didn't actually make it public or make it private. All right, neither of them are public right now. They're both private. All right, how do we know they're both private? Well, that's through our route tables. So if we go look at our route tables, you'll see, let's go ahead and filter by our coding with Kali VPC. You'll see that we have a default route table, and the only routes that we have is local, and that's our CIDR block for the whole VPC. So what does that mean? That means that everything within the VPC is able to communicate with each other right now. So our public subnet is not actually public, all right? So we're gonna now add our public route table, so that way we can actually connect to the internet. We don't need it in order to connect to the internet, though. The route table needs to go somewhere, and that's going to be it needs to connect to an internet gateway. So we are going to create the internet gateway first. Okay, so how would I do that? Well, I can go to my Terraform registry, which is going to tell me all of the resources and how to put them up. And I'm going to say I want an AWS internet gateway. And here is the resource for the AWS Internet Gateway. All right, and an example usage, and you can kind of see how else it's used. Okay, so I'm going to just copy this block of code here, and below my private subnet, I'm going to paste it in. So the resource that we are provisioning is an AWS Internet Gateway. I feel fine about calling it GW. That's fine. All right, so now we're getting into some cool stuff, right? You can see that similar to our subnets, we're saying that the VPC ID is going to be AWS underscore VPC, right? That's this resource. And then dot main, that's the name of our resource, and then dot ID, all right? So each resource has an ID. Well, it should, but I haven't tested every resource on Terraform, so I don't want to speak untruly. All right. How can we see some of this? Okay. So what do we want to do? In order to see this, we want to actually use an output. All right. And wow, good job, Copilot knows exactly what I want. So I'm going to name it VPC ID. Okay. Output is going to spit out whatever I tell it to in my terminal after the resources are provisioned. So what do I want? I want the value to be and then I'm going to not let Copilot do it. So I want my value to be AWS. And see, these are all my resources that it's pulling up that I can choose from. So I want it to be my AWS underscore VPC. All right, the name of that VPC resource is main. And then and see, these are all of the things that you could do. You could have all of this output, all right, about your VPC. All right, but we just want the ID. So I'm going to go with, ID. All right. Now, do I need to output this? No, but there's cases that we'll get into as we get more complicated where we will want, and even in this challenge, we will want to output something to verify. All right. So now we have an output too, and then we have an internet gateway. I don't want to call my internet gateway main though. I want to call my internet gateway coding with Kali internet gateway. All right. And then let's go ahead and give it a try and say Terraform apply. All right, so it's going to add one and then it's not going to change anything, okay? And then you can see changes to output now. We see it's going to add an output of VPC ID and it's going to show us our VPC ID. Now, if we didn't have the VPC created already, it would say known after apply, but we already have the VPC. And when it went to check the state, it saw like, oh, that exists. All right, and even though we have 1, 2, 3, 4 resources, it's only adding one because the rest of them already exist. All right. So we can go ahead and say, yes, we want to create that internet gateway. So now let's go ahead back to our console and let's take a look at what we did. So we did an internet gateway. You can see our Coding with Kali internet gateway is up and it is attached, okay? If you remember when we did this in the console, we had to do this in 2 steps. So let's do test internet gateway. All right, we had to name it, right? And we created it. And then once we created it, we had to go to actions and attach it to a VPC. And then we had to select, why don't I don't have any VPCs. Oh, did I not create this internet gateway? Interesting. Well, this was just to show you how it works. I don't really, we're not going to worry about it. I'm going to just delete it. But you get the point. It would have been 2 steps in the console. And in Terraform, we can just do it in 1 step because it's already attached to the Coding with Kali VPC. All right. Next, so having the internet gateway doesn't really do anything for us because there's no routes associated with it. So that's what we need to do next is we need to create that public route table, all right? And we need to add the route that will go to the internet gateway, all right? So let's first just create the route table. I like to do everything in very little steps so that way I can really understand what the code is doing. All right, so AWS Internet Gateway, we don't need that anymore because we created it. So I want to look at an AWS route table. And I'm going to take a sip of coffee here. Let's do the route table. All right, so you can see that we have the resource, right? It's called AWS route table. They're naming it example. They are saying that it is associated with a VPC, and then they're adding the routes, right? So the first route is going to be that local, anything within that CIDR block that our VPC is in, it can communicate with. And then the next thing we want to do is it's going to be able to communicate with the internet gateway that we have. All right, I'm going to leave this blank because I just want to see it pop up, and then we'll add that after so we can see what goes different. And then you can see that it also has the routes for, it looks like they're having some egress routes here too. We'll look into that. And then the name. All right. Oh, and then you can remove the routes by just making the route an empty array. That's cool. Okay, so I'm going to copy this block. I'm going to get rid of my output VPC ID because I don't need it, and I'm going to paste my block in. So I want this to be a public route table. Perfect. Like that. And then VPC ID is going to be AWS. Okay, also, did you see how this is like white? It's white because we don't actually have an AWS VPC resource named example. But if I change this to main, it turns blue because we do. So it's actually connecting to what we need it to connect to. All right. So the CIDR block that we're using is going to be this one here. So we can go ahead and pull this down. I want to put that here instead. All right. And then I'm going to get rid of this gateway ID, and I'm going to get rid of this here. And I'm going to call this my public, I'm going to call it Coding with Callie public route table. All right, and then I'm going to do Terraform apply. Now, if you're like, do I need this line? Do I need this line? Just test it, apply, and see what happens, okay? You can see that we're going to add one, which is going to be our private route or our public route table, and then you can see that it's changing the output. It's going from outputting the VPC ID to outputting nothing. Bless me, sorry, I just sneezed. All right, so we have an error on 49. So this resource is our issue. Oh, apparently we have to have a gateway ID. So I guess we'll just do it. All right, so our gateway ID is going to be our, if we look, and it already had it right, but let's just make sure we understand it. We want the resource, this, right? So AWS Internet Gateway. Right, that's going to be the resource. And then we want the name of our resource, which we named it GW. And then we want the ID of that. All right, and it turns blue because it knows it. All right, so now let's try it again. All right, so what is it doing? So it's destroying. Did it create one just then? I don't feel like it did. But this is what's kind of good about doing this with Terraform is then you can also still go and check. Okay, so it did create a public route table and it did make it the route to 10.0.0.024. All right. So let's go ahead and it's going to replace that by adding our gateway ID to it. Okay, so it's saying that the creating the route and the route. So our route here is the issue, our CIDR block here. And this is also why we should do more research on CIDR blocks so we understand it a little bit more. It's equal to or more specific than one of the VPC's CIDR blocks. This route can target only an interface or an instance. Interesting. All right. So I'm going to go look at okay, I need to sign in again. I'm going to go look at the route table that was default to this VPC when we created it, and I'm going to see what CIDR block they use because I want to use the same one. So they do use this CIDR block here. What is going on with mine that is different? So let's just paste this in. It looks the exact same. Let's go ahead and do Terraform, destroy everything, and see if just something weird is happening or if we are doing the same issue. All right, and then let's do Terraform, apply. Okay, so this is going to be a great case for GitHub Copilot. All right, so I'm going to go ahead and I'm going to say, what does this error mean? And I'm going to let GitHub Copilot explain it. This error is related to the AWS VPC configuration in your Terraform script. It's saying that the CIDR block you're trying to assign to a route in your route table is either the same as or more specific than the CIDR block of your VPC. In AWS, a route in a route table cannot have the same destination CIDR block that is the same or more specific than the VPC CIDR block if the target is an internet gateway. Oh, okay. So I think what this is saying is that like this is specifically a route to my internet gateway, and this is the CIDR block for it. All right. It's still hazy though. So let's keep reading. Okay, to fix this, you need to ensure. So basically, yeah, okay. Callie, stop trying to explain. Keep reading. To fix this, you need to ensure that the CIDR block for your route is less specific than your VPC CIDR block. For example, if your VPC CIDR block is 10.0.0 /24, your route CIDR block could be this to represent all IP addresses, which is a common configuration. Yes. So this route with the gateway ID here is saying that we want the CIDR block of this to be able to use the internet gateway is what my thoughts are. So what I'm going to do is I'm going to go ahead and I'm going to highlight it and click. And then I think I have too many, I have codidioms too. So if I'm going to have to manually do it. So I'm going to explain this now, this block here, to get more information to verify what we're thinking. This block of Terraform code is defining a route for a route table in VPC, okay? The CIDR block line is specifying the destination CIDR block for the route. The CIDR stands for classless interdomain routing, a method for allocating IP addresses and routing internet protocol packets. All right, so in this case, that block represents all of the IP addresses in that range. The gateway ID line is specifying the internet gateway that the route is associated with. Okay, it's providing a path for traffic going to and from the internet. In this case, AWS Internet Gateway.gateway.id is a reference to the ID of the internet gateway that's defined elsewhere in your Terraform configuration. This means, I think this is the sentence that I've been looking for. This means that any traffic that matches the CIDR block of this will be routed to the gateway. However, as per your error message you received, if the CIDR's gateway should be more. Okay, so basically we're setting up an internet gateway. We set up an internet gateway, and this is the route that we're saying that we want in the route table. But we're saying in the CIDR block that we want traffic from this CIDR block to use the internet gateway. But that doesn't make sense because the internet gateway is for all traffic. So we want it to be this, which is the all traffic instead. Okay, so this is setting up this route for our public gateway. All right. I hope that makes sense, but we can go over it more if it doesn't. So now let's try to Terraform apply it. I was thinking that we needed that each one of these was a route, but that's silly. So I'm glad that we had GitHub Copilot to explain that to us. And now our error is gone. So thank you, Copilot. You did a good job. All right, so now let's go ahead and take a look at our public route table, and I'm going to refresh the page. and the route table is not found because I deleted that one. So refresh the page. Now let's go into here. So you can see that this local route is being set up for us. So we don't actually need to set it up. That's where I was confused. And then what we just set up is we just set up the destination and target of the internet gateway. So we're saying that here, all traffic can use our internet gateway. All right, cool. So now we have our route table and our internet gateway. And I'm trying to see if we should do anything else in this video. It's been a pretty long video. So we're going to end it here, and then we will pick up and actually try to create an instance and use this route and the internet gateway in the next video. All right. So the next thing that we want to do, that we did not do before, but we did when we were in the console, is you can see that if we click over to subnet associations, we have no subnet associations. So that means that when we actually put an EC2 instance in our public subnet, it's not going to be associated with our subnet, with our route table, so it won't get to connect to the internet. I was gonna like do a gotcha where we like create the EC2 instance and then debug, but I figure since we're already on the route table, let's just do it. And we're not gonna do it on the console, we're gonna do it with Terraform. All right, so let's go back to here, and then we're gonna say association. And you can see it's a pretty easy resource to do. All right, so AWS Route Table Association, what should we call it? I'm going to just call it Public Subnet Association. I like that, GitHub. Thank you. All right, and then we have to actually correct this. So AWS subnet.publicsubnet.id is perfect. And then the route table ID is going to be AWS Route Table, Public Route Table ID. Perfect. All right, so now let's go ahead and Terraform apply and see how we do. So yep, it's going to create our association. Let's go ahead and say, yes, please. And that has been added. So let's go ahead and we'll make this bigger, and let's refresh this page. And we can see that when we have subnet associations, that woohoo, we have our public subnet. All right. So let's go ahead now, and what we want to do next is we are going to create our public EC2 instance, okay? And if you remember from the last challenge, the goal of our public EC2 instance is just to redirect traffic to the instance in our private subnet. All right, but for now, since we have to install NGINX on it anyway, we're gonna set up the instance, and then we're gonna try to see that NGINX homepage. Oops. So let's pull this over again. There we go. And we are going to go up, and instead here we're going to say AWS instance, and we are going to find the official instance resource on Terraform registry. And let's load it. There we go. All right. So if you look at the resource here, it's looking like it's getting the data. So when you see data, what it's doing is it's going and pulling data from AWS and giving it to us. All right. So it's looking up what is we're trying to get the AMI for Ubuntu. All right. It's looking for the most recent Ubuntu AMI. And then it's filtering the name it wants is this. The virtualization type is this, and the owner is that. I don't know what all of that is. We're going to keep with the AWS Linux. And for now, I'm going to go ahead and just copy and paste in the AMI from the console. But this would be a great like exercise to do, is to figure out like how can we get the most recent Linux AMI. So add that too if you have extra time. Go ahead and try to play around with this data block and see if you can do it. All right. You can then see for AMI, they're using the result of the data, what AWS returned, all right, and the ID there. Okay. So we are just going to copy this guy here. All right. And then we are going to add it here. All right. So we're going to say resource AWS instance, and then I am going to put public instance. All right. The AMI that we're going to use, I'm going to go to the console to get Copilot is like, let me pick. Okay. And so I'm going to go to launch instance so I can just find the AMI. And here's the one that we're going to use. And we'll put that in there. And then I don't want to name it Hello World. I want to name it Coding with Callie Public EC2. All right. So this is good, but you'll remember that we did more than just this because this is going to use the default VPC. All right. And we don't want to use the default VPC. So we're going to kind of scroll through and we're going to try to figure out. All right. So network specification example. Perfect. Okay. So let's go to the AWS instance. That's not, all right, and then we have a subnet ID that we can put on it. So let's go ahead and add that. So we have our AMI, we have our instance type, and then, yep, we want to do our subnet ID is going to be equal to AWS underscore subnet dot public subnet dot ID. So now when it creates this AWS instance, it's going to put it in this subnet. So that is perfect. All right, what else do we need? Actually, you know what we're going to do? I'm trying to decide what I want to do. Let's have a gotcha here. All right, we're going to have a few gotchas coming up. Okay, so the first thing we want to do is Terraform apply. Let's take a look at what it's planning to do. All right, so it's going to create one resource, and what it's going to do is, yep, it's creating our AWS instance. All right, I'm fine with it creating that. So we're going to go ahead and say yes, and now it's creating, which, yay. Still creating. All right, so let me open this up now that it's created, and let's go to instances. And you can see that it's running, okay? But the first gotcha that we have is that we don't have a public IP address because we didn't specify that in our plan. So anything that manually you had to do in the console, you have to specify as well in Terraform. All right. Then let's go to our Connect tab, and we have our second gotcha. We have no associated key pair. So we can't SSH into this instance because we don't have a key pair, right? Remember that we created a private key file on our computer and then we used that private key in order to SSH into it. Well, we can't do that if we don't have a key pair. So let's solve each of these problems one at a time, okay? So I want to add a public IP address. So I'm going to type in Terraform EC2 public IP. So let's just look for public. Where do I see public? All right, so public IP, that looks like that's going to be an attribute that's part of this. So let's take a look. Oh, and it looks like we have associate public IP address true. So I'm going to go ahead and give that a try. So let's go and see if we can find that in the docs. Yep. All right, argument reference, optional, whether to associate a public IP address instance with the VPC in the VPC. And we do want that, right? So let's go ahead and Terraform apply. Again, that fixes one of our gotchas. All right, and you can see that we're going to destroy the EC2 instance that we did before, and we're going to add a new one. Let's go ahead and say, yes, please. So it's destroying it. And then after it successfully destroys, it's going to create a new one. All right, so while it's doing that, let's go ahead and take a look at key pairs. Okay, so I'm going to type in Terraform EC2 key pair. It looks like there's already a Terraform registry resource for that. And it looks like it's not too bad to create. All right. Still destroying. So let's read through this. Okay. Provides an EC2 key pair resource. A key pair is used to control login access to EC2 instances. Currently, this resource requires, okay, so this is the issue here, right? Our goal is to, in one terminal command, create all of the infrastructure, okay? So this resource here that we're doing is going to be referencing a public key pair that already exists, okay? And that would mean that we would have to create the public key pair, okay? So we need to also look at, we're gonna need to look at how we do that with Terraform as well. All right, so let's open up that. Oh, it looks like the resource is added, so we'll go check that. But let's do Terraform EC2 private key. And you can see that I did a lot of research on this before I started filming to figure this out, because I did not know how to do all of this beforehand. Mm, mm, mm. There's scan through. So it looks like they're creating the key pair in their terminal. All right. I might have to go and look at my bookmarks, because yeah, they're using the resource here. All right. It's not exactly what we want, but let's go ahead and go look at our EC2 instance. Let's see how we're doing. So yep, see how it terminated that one and then it created a new one, okay? So if you look, now we have a public IP address, which is what we want, but we still have no associated key pair. All right, so I'm on another tab right now in a different window, because I'm gonna go search through my bookmarks, see if I can find the exact resource that helped us before. I'm looking. All right. I'm not sure I'm finding it. That is okay. All right, so I'm going to end this video here so I can go find the exact article that we can go through that explains it really well, and then I will kind of jump back on in the next video. All right, we are getting close. Let's figure out how to make this key pair. I found the article that is helpful. So basically, it explains what I was saying before, that you can create a key pair resource, but then you are going to have to have a private key pair associated with it. All right. So we can use this TLS private key resource in order to create it. All right. So this is not through AWS. This could be a different provider, but that's okay. So let's go ahead and add it in, this code block here, and see what happens with our Terraform. All right, I'm going to add it right above our public instance, because in my mind that makes sense as I'm reading my code, but it's pretty much just like for readability. So I'm going to call this private key. All right, and then that's fine. All right, this is going to create our private key. So let's go ahead and do Terraform apply. All right, so you can see that it says inconsistent dependency file. So the reason is that we need a new provider for this. We need the HashiCorp TLS provider in order to create this key pair for us. So I'm going to go ahead and hit Terraform and hit upgrade, and you can see that it's been upgraded. All right. So then now we should be able to click Terraform apply. All right, so it's going to create us a private key now, and we can go ahead and click yes. Perfect. All right, and you can see now in providers, we have AWS, and then we also have TLS, which is great. All right, so next, what are we going to do now that we have created this private key? Now we should be able to use Terraform's resource. All right, so we will go ahead and add that. Okay, and we are going to, sure, I can leave it as that. I'm just going to call it key, I think. All right. And so here it's saying the key name is going to, they're storing it in a variable. We haven't gone over variables yet, but the idea is to make your Terraform more modular. You can add a variable. So that way you name the variable and then you can use the same plans, but add different names in, different AMIs, different things. We'll get into that eventually, but for now we are just going to call it coding with Callie key. And then we are going to, for the public key, we are going to, what are we going to write? It looks like it's trying here. So I'm going to say yes, we'll give it a try. And let's go ahead and do Terraform apply. All right, so you can see that it creating a public key for us and a private key for us. And let's go ahead and say yes. Perfect. Okay. Next, what we're going to do is we also need to create, scroll down. We need to store the key pair, right? Because when we SSH, we want to eventually SSH into this instance. Okay, so in order to SSH into the instance, we need to be able to have the file there. Okay, so that's going to be the next thing, right? So the private key needs to be stored in the instance in order to SSH into it. So we have to create a file for it. So let's go ahead and do this. Local file, and then we are going to call this coding with, let's call this private key. All right. The content is going to be our TLS private key, like that. Right. So the difference is their private key was just named RSA up here. Maybe. Oh, I think they have a typo in their thing. So they named it here, but then they're using this here. I think they just changed the name. But anyway, so the name of our private key, we made it was private key, and then we're going to get the PEM after it. For file name, we don't have any variables, so we're going to call it coding with Callie key PEM. All right, so now let's go ahead and Terraform apply. Once again, we have a problem, and that's because we need a new provider. So let's go ahead and take a look, and you can see that now we have local as one of our providers too. All right, now we can go ahead and do Terraform apply. And it's going to create that local file. So let's go ahead and create it. And now you can see that we have our coding with Callie key in our files here. All right. Very cool stuff. All right, but if you notice, it's still, when we refresh our page, the instance doesn't have the key. And why is that? Well, it doesn't have the key because we didn't add the key into our plans when we did it. But now we can. So let's go ahead and see if it's going to get it. And it is. So key name is going to be AWS key pair, right? That's this resource here. Dot key, because that's what we named that key pair, and then dot key name, which is going to be coding with Callie key. Okay, so let's go ahead and Terraform apply. All right, and interesting. Oh, we didn't save. All right. So basically, I didn't save, so it didn't notice that I changed any of my infrastructure. But now it should see that my instance is different. So it's going to destroy the instance that we had, and then it's going to create a new instance because I am adding a key pair, and you can't do that in place. So it's going to destroy, and then it's going to so this instance is never going to work. You can see in our instance is that we have this one is shutting down. This was the one from the last video that we didn't have the public IP address with. So you can see it's still destroying. We're going to have to wait until it terminates before it can then create the next one. So we'll just hang out and hopefully this works. But yeah, I will link this here. But yeah, do notice that the RSA name is different than this example up here. So you'll have to create your own names and play around with it to make sure that it's working. Okay. I also found some like other typos too, but that's okay. So like this, right? It says TIS instead of TLS, which isn't the end of the world, but I'm too impatient. All right, so it terminated it, and then now it's creating the next one. Still creating. Should be done though soon because it says it's running. Okay, perfect. So now let's go ahead and refresh and let's take a look. So we have the public IP address, and if we go to connect, we can now connect. Okay. So let's try to connect to our instance here. So the first thing I'm going to do is run the chmod. So I can change the ownership on the PEM key because this is my first time using the PEM key. And then I can SSH into it, hopefully. And another gotcha. I can't SSH into it. Let's go investigate why. All right, so first off, let's make sure that it's passing the checks. All right, so it's still saying it's initializing, so that could be it. But what I think is happening is we did forget one thing, and that is we forgot that we didn't make any security rules. Although it looks like for inbound, we're allowing everything from everything and everything for outbound, which is not great and not what we want to have. All right. It still says initializing. All right, I'm going to pause here so that way I can wait for this to finish and I will resume once it's ready. All right, so it took a while to load, but this is what I mean. The status check, 2 out of 2 checks passed. Okay, so now that we have that, let's take a look if that was our issue. And I just clicked enter to SSH into my instance, and that wasn't the issue. All right, so I'm going to Control C to stop running that because eventually it would turn timeout, although I guess I'll just let it time out and pull down. Now, what is the reason for that? The reason is that when we set up our security, we didn't actually do any security. All right. So it's allowing all ports from this security group to go in and all outbound, right? But it's not letting us do any SSHing access. Okay. So we need to set up the security group ourselves with Terraform because, like I said earlier, anything that you manually did in the console, you have to do with Terraform. So let's go ahead and make a security group. All right, so let's go ahead and do AWS. Maybe, I don't know what it would be called, instance security group. All right, so here's the security group Terraform. All right. Allow inbound traffic. All right, so it looks like they set up the security group here. They're naming it and describing it and associating it with a VPC. And then what they're doing is they're using ingress rules and egress rules for what their traffic is going to be. All right, so let's go ahead and set it up similarly. All right, so I'm going to copy this. And we are going to think through what we want. All right, so we want security group, coding with Kali, public security group. All right, we want to say allow traffic. Allow SSH inbound traffic. And we also want to do and allow SSH and TCP inbound traffic and all outbound traffic. All right, so we'll use the main and we'll name this coding with Callie public security group. Okay, so the SSH is we want to be able to SSH into our instance, which you can see timed out, and then we want TCP inbound traffic. So NGINX runs on port 80, so we want to be able to, on port 80, ping our NGINX server. Then we also want all outbound traffic, so when we're in the instance, we want to be able to contact the internet however we want. Okay, so now next we want to set up a resource, and then we want to say AWS security group rule, nope, security group ingress rule, and then we are going to say coding with Callie public security group ingress, and let's start with SSH. All right. So the security group ID is, yes, AWS security group, right? Dot coding with Callie public security group dot ID type ingress. That makes sense. I'm curious, it was bringing up, it feels like we don't need type ingress because it's an ingress rule. What's happening here? All right, so I'm going to get rid of type ingress because I'm curious. It does not like this. AWS security group, coding with Callie public. Interesting. All right, I think I'm going to do it this way instead. So basically in the public, in the resource, we can just define ingress and egress like this too. So I'm going to do that. So let's do ingress. All right. Egress. I'm going to just let it do its thing. Okay, so this is the typical egress. You can see it here. We don't have IPv6 CIDR blocks, so we don't have to worry about that. Basically, we're saying that we want to allow all traffic for all protocols from our EC2 instance out, okay? For ingress, we are going to have two rules. So the first one that we're going to have is from port 22 to port 22. So that's going to be our SSH port. So protocol TCP, all right? And then CIDR blocks all. We want it to be our own public IP address, but that is going to be something that I think we'll do in an iterative manner. So we'll look up figure out how to get our public IP address in here later. So I'm going to add a comment so that way I remember to do it. So figure out how to get personal IP address instead of all. Okay. So we'll do that, and then we need that will allow us to SSH. Then we need another ingress where, for port 80, where we can do TCP, and we want it to be able to come in from all traffic there, so that makes sense. And then we're going to name this security group. All right, so now we need to add that security group to our instance. So I'm going to let GitHub Copilot flesh it out for me, but yep. So we're going to say our security group IDs that we want to use, because you could use multiple security groups, but we're going to use our AWS security group coding with Callie public sg.id. All right, so now after all of that, let's run Terraform apply and see what happens. All right, and let's say yes. All right, so I went ahead and added my security group. All right, let's go ahead and see if it successfully, oh, I didn't save. Yeah, I was gonna say it didn't seem like it added it to the actual EC2 instance. So let's do that again, Terraform apply, because I'm thinking it's gonna have to delete the instance. So let's see. All right, to change. Oh, okay, it looks like you can update security groups in place, so we won't have to actually delete the instance. which is nice. All right, so it's modifying our security group now. So let's open this up and let's take a look. So we're going to refresh and nope. Interesting. Go to security. Oh, and now you can see now we have inbound traffic from 22, which will allow us to SSH. And then we have traffic for port 80, which will allow us to view our NGINX image once we do it, which we will worry about the NGINX image later. But for now, let's go ahead and let's try to SSH into our instance. And woohoo, we did it. All right. I'll see you in the next video where we try to, through Terraform, download NGINX and get it started. All right, see you in the next one. All right, so we've added a few different providers, but we haven't fully fleshed out the required providers section and the make sure all of them have provider blocks too. So if we're trying to do this right, let's go ahead and go back and do that, okay? So the first one we have is I looked up the Terraform registry for TLS. And you can see the version is here. So we can go ahead and add TLS. And you can see source would be HashiCorp/TLS. That makes sense. And then version is going to be 4.0.5. Okay. So GitHub Copilot is telling me to use this. So what I'm going to do is I'm going to highlight this and I am going to ask GitHub Copilot to explain what it's doing. Make sure I fully understand what source version I should put. All right, so the block is specifying provider configuration for the TLS provider. Providers are responsible for understanding API interactions and exposing resources. All right. The TLS provider specifically is a Terraform provider that provides resources for working with transport layer security certificates. This is useful for creating certificates for testing purposes. The source HashiCorp/TLL line is the source of the provider. In this case, the provider is sourced from HashiCorp. Version tilde little greater than symbol 4.0 line is specifying the version constraint for the provider. This symbol is a special symbol of Terraform, meaning approximately greater than. It's saying use version 4.0 or any minor version of 4.0, but not to use 5.0 or any major version updated. All right, so we are saying that we can use anything between 4 and 5, and we are at 4.05 for like the latest, so that seems like the good one to do. All right, so then let's go ahead and go down and see what other providers we are using. All right, we're using local file, so let's go ahead and look up local file. And that is another resource. You can see the version is 2.5.1. All right. So what we're going to do then is we're going to scroll up and I'm going to add that I want provider local file. And that should be good. Then let's go ahead and add this here, local file. And source, I think I'm just going to put source 2.5 and up. All right. Then let's look to see more. Do we have any other providers that we forgot? No. All right, perfect. So now that we have that, let's go ahead and test to make sure that adding those versions didn't mess anything up. So I'm going to click Terraform apply, invalid provider local name. So I'm going to also Copilot that. And so you can use Copilot for errors, and I can just say, explain what this error means. And it should tell me. I'm also going to look at my documentations. Okay, so it looks like local file is a resource from local. That makes sense. That's kind of what I suspected, but I was a little bit confused that there was because local file is the resource. I'm sure if I would have kept reading and not been lazy, that we would have seen that local is the provider. So let's check local as the provider, 2.5.1. So we should be good. All right, let's go ahead and Terraform apply again and see how we go. Mhm. And all right, so it looks like it has some things 11 things to add. So we're going to go ahead and we're going to say, yeah, go ahead and apply that. Let's take a look. All right, so now all of our things are creating and our public instance is creating. So I'm going to go ahead and sign back into AWS. Okay, so yep, I'm into AWS. So let's go to EC2. Says we added it. So that's exciting. So here it is. So I'm going to go ahead and I'm going to try to connect to it now from my terminal. All right. I'm going to pull my terminal over because it's on another screen. And then I'm going to from my chmod. Oh, well, duh, because I have to do it from in here because this is where my file is. So let's add that. Now let's SSH into, and woohoo, we did it. We SSH'd into our, what's it called? Our instance. Now, the issue with this though is that we don't want all IP addresses to be able to SSH into the instance. You can see here when we are setting our ingress rule, we're setting that any IP address can, and we want to instead figure out how to get our personal IP address. So over the past few days, I went and did some research and I found that we can use the HTTP provider to do this. So I'm going to go ahead and delete this comment, and this is what we're going to work on next. Okay. So we are going to want HTTP. So I'm going to say HTTP. All right. And I'm going to let it fill in, but then I'm going to check. So that's in 3.2.1, but let's actually go and check the latest. So this is HTTP version 3.4.2. So I'm going to put it at 3.4. All right. And then I'm going to add it here. And now we have HTTP. Okay, let's go back. All right, so the first thing we're going to do is we're going to use a data block. And that means that we want to get data from a provider. So what we want to do is we want to get data from the HTTP provider, and we want it to be my IP address. All right. So we need to give it a URL in order to ping, because that's essentially what HTTP is it's going to be a service that can send HTTP requests. So we're going to have URL HTTP sipinfo.io. All right. And I've already tested this and it's like not perfect. So this article wasn't perfect last time I tried it, but it is helpful. So I'm going to go ahead and bookmark it so I can share it with you. But just note that it might not do exactly what we need it to do the first time out. We might have to keep doing some searches. All right, so then I'm also going to add an output block. And the reason why I'm going to add an output block is because I want to test just that this works and that we are able to get our IP address. So if you look here, they're doing this format thing where they're adding a /32 onto it, and then they're doing data.http.ipinfo.body. So I'm going to do data.http, and then I'm going to do .myip because that's what I named that data block, and then I'm going to say .body .ip. All right, and then I'm going to actually say because this I'm just making sure. Yeah, our security group still has the 00, so we didn't change that. So if I do Terraform apply, let me exit out of my instance and Terraform apply. All right, we have an inconsistent dependency lock file, and that's because we added a new provider. So when we add a new provider, we need to initialize our Terraform state again. All right, so now we can do Terraform apply, and let's see what issues we have. All right, so we have a warning that body is deprecated, so we might have to look into that. I did a typo, which isn't impacting things, but impacts readability. So I'm going to switch that to my IP, and then it can say that it can't access attributes on a primitive typed value string. Okay. So we're going to have to play around with this a little bit. All right. So what I'm going to do is I'm going to go to ipinfo.io, the trusted source for IP address data. All right, so then I can go to docs so I can figure out how we're doing this. So here you can see that we are using auth. There's a token, and I don't have a token. So here you can see we try to automatically detect when someone wants to call our API versus view our website, and then we send back the appropriate JSON response rather than HTML. We do this based on the user agent. There are a couple ways to force a JSON response. One is to add /JSON at the end of any request. Okay, so if I do this, let me open up my Postman. You can see I already have this loaded in. So first, let's go ahead and just do get ipinfo.io. All right, you can see it's sending a request, and then it comes back with an HTML page, right? Because that's essentially what we're doing here when we type in ipinfo.io, we are getting an HTML page. But if we want to get the JSON, we have to add /JSON, and now you can see where I'm at, okay? Which I'm not sure if it's bad for me to show you my IP address or not. All right, so if you look at Postman, which is doing the same thing, we can add /JSON onto it, and then we get back the information. All right, so let's go here, and we want to add the /JSON, and then we want to go ahead and apply again. All right, and we still have can't access attributes on a primitive type value string. All right, so let's go ahead and look. And if you look here, we're getting a JSON object back, and we can just do, in order to get the string, we can just do .ip. So if I just want to see the .ip, I can do this. Maybe. On 38, oh wait, unsupported attribute. Oh, .id. I am going a little bit cuckoo for Cocoa Puffs tonight. I'm typing typos all over the place. All right, so now it seems like it's working better. And you can see, that oh wait, oh, because I'm getting the ID. I don't want the ID. Okay. We do want body, but why is it not? All right, so I think we'll try again, and then let's do a little bit more with our error message. All right, so I'm going to go to GitHub Copilot, and this is the good thing about GitHub Copilot is that you can use it to kind of like help you figure out what you need to Google, okay? So normally I would just Google this error, but now that I have Copilot, I can kind of throw it through there and read about it, and then it gives me more keywords to look up if Copilot doesn't make sense. So saying I'm trying to access an attribute on a primitive type value, specifically a string. In my code, I'm trying to access the IP attribute from there. However, body is a oh, so I have to convert it. Okay, so body is a string. So I have to decode the JSON first. Okay. If the HTTP response body is a JSON object and you want to access the attribute from it, you need to first decode the JSON string into a Terraform object using JSON decode. Okay, that makes a lot of sense. And see, that worked on the first go of things, which if you see, if we would have just kind of kept looking. So we want to decode that JSON response that we get back from pinging this URL. And then once we decode it, we can then look at the IP property. So didn't save it. I'm going to clear my terminal so I'm not getting confused by the different messages. And then let's take a look. All right. And now it looks like we have an IP address. So good. That is exactly what we want. Now let's go ahead and look back at, so I can go ahead and bookmark this too for you guys. Let's go ahead and look back at this now. All right, so we're getting the data and we know how to get our IP address now. So you can see that they're adding it as a CIDR block. And the way that they're adding it as a CIDR block is they have to add the subnet onto the end, okay? So basically when they're using format, they're just adding this percentage S means that this is going to go in the percentage S place. It's like a variable type of a thing, right? So you're saying like placeholder /32, and then you're saying comma, put this in my placeholder. All right. So if I go down to my security group, right here, instead of saying I want to be SSH into all places, I can say format, and then I can follow some of this. So I'm going to say %S/32, comma, and then I can go ahead and from my output block that I did, I can go ahead and take this and I can plop it in there. All right. I don't need the output block anymore because I don't need to use it. And I should hopefully be able to Terraform apply. And if not, we will read the errors and go from there. All right, so this is just saying the warning, which would be something to look into about body being deprecated. We would look into that from here. So I could look into IP info. Let me like search body, not coming up. So let's go with IP info. Body is deprecated. Right, this looks like we're getting the same errors. This person. Oh, looks like we can use a different website. This guy here. All right, so is response body. So let me actually go back. And instead of doing .body, let's do response body and see if that does anything. And let's say no. I'm experimenting a lot just because I really want to understand what's going on and make sure I like know the ins and outs. But if this is super boring, you don't have to listen to this part. Okay, so we're still getting the error because on line 119, we are still using body instead of response body. And that's actually, I was looking up IP info, but actually what we'd want to look up is HTTP body is deprecated, is my guess. So yeah, body is now deprecated and has been superseded by response body. All right, so that is how you can kind of look that up. So then let's go ahead and say, no, we don't want to apply that. And then let's say Terraform apply because we made an edit. And hopefully we won't see a warning. And we don't see a warning, so yay. So now it's modifying my security group. So let's go back over to here. Let's go to my instance. I'm going to just refresh the page and then go to security. And you can see now that we are allowing SSH traffic from my IP address. Okay, so now let's go ahead and take a look if we can connect to our public instance. Because I'm on my IP address and we can. I don't really have another computer that I can test out if I can come from a different IP address in a different area. So this is just what we're just going to be happy that it worked. And in the next video, we will start working on our private instance and our private security group. See you soon. All right. So hopefully we can move a little bit quicker now that we already have created a EC2 instance, because now we need to create our other main EC2 instance that will store our application, which is the private instance. Okay. So I'm going to go ahead and I'm going to find my public instance resource and I'm going to copy it and I'm going to paste it. And then instead of public here, I'm going to say private instance. I'm fine with using the same AMI, the same instance type. For subnet ID, I'm going to use my private subnet ID instead. I am not going to associate a public IP address with it, so I'll make that false. And then we can use the same key pair. And then here we have a security group, and we're not going to want to use the same security group as before. So I'm going to copy my security group from the public one, and I'm going to paste it in, and then I'm going to change the security group to being private. So coding with Callie, private security group, name, allow traffic. All right. I'm trying to read what we want to allow. So we want to allow us to egress to anywhere. That is fair. And we want to allow ingress on port 80 because we'll eventually be using our NGINX server on the public instance to redirect to the private instance, but we don't need to be able to allow all IP addresses. What we can do is we can go and grab the CIDR block for our public subnet. And we can throw it in here. The next thing that we need to be able to do is we need to be able to SSH into it, but we want to be able to SSH into it from the bastion host. So for now, I'm just going to say from anywhere, and then I'm going to add a comment, and I'm going to say allow change CIDR block to be security group for bastion host. Okay. And then I'm going to say, I'm going to name this allow some traffic. And I'm going to say allow SSH traffic from bastion host, TCP traffic. Yeah, inbound's fine. TCP traffic from public subnet and all outbound traffic. All right, cool. And that security group is going to be in our main VPC. All right, we will name this Coding with Callie private subgroup. I also feel like this allows some traffic name. I'm going to take it off because I kind of want this name to be there. And I felt a little bit confused when I saw allow traffic before. So I'm going to take it off my public subnet too. All right, so now with having saved that, I should be able to say Terraform apply and take a look at how we did. All right, so we're adding the private security group. We're adding the private instance. I don't really know why we're not changing the other security group, but I'm going to just go ahead and say okay. All right, so it says your requested instance type T3 micro is not supported in your requested availability zone US East 1. All right, this is actually a good gotcha moment, really just a gotcha moment for me. But when we create public and private subnets, we're creating them in availability zones. So I set my region equal to US East 1, but because I didn't set my availability zones in my public and private subnet, it's just kind of picking any availability zone from US East 1. So what we need to do is we need to add availability zone, and then I'm going to just stick with US East 1A. And I'm going to do that for both public and private subnet. Okay? So now I should be able to Terraform apply, and it should be able to do that for us. So my public subnet is going to be replaced. My private subnet is going to be replaced. Lots of things are getting replaced. So pretty much 5 to add, 4 to destroy. Let's go ahead and say yes. So we're gonna have to wait for all this to destroy. So what I'm gonna do is, since I've already been sitting in silence just staring at this for a little bit too long, I'm gonna just pause and then unpause when it comes back, but it should take a while. Did not take as long as I expected, but here we go. We have them back. So I'm gonna make this bigger so that way I can see it. And we have our public EC2 instance and our private EC2 instance both running, both initializing still. Let's see, we should be able to connect to the public one and we shouldn't be able to connect to the private one. So I'm gonna go ahead and get my SSH command. Let's paste it in. Not looking good. Curious if it's because we're not passing the status checks yet. We've been initializing for a while. Probably time out. All right, I'm gonna pause and then I'll come back when the checks are run. All right, so I went ahead and finished running the like waiting for it to become ready, 2 out of 2 check. But what's confusing me a little bit is I don't have a public IP address here, and I'm a little bit confused as to why I don't have a public IP address on my public instance. So I am going and looking at, okay, so now I'm looking at my public instance and I see associate public IP address true. So that's a little bit confusing to me. So I then went ahead and ran Terraform apply to see if anything is not correct in here. And I don't see that. So what I'm going to do is I'm going to Terraform destroy and then Terraform reapply. I'm going to pause the video here. And once everything is back up, we're going to see if the public IP address worked. Maybe me changing the availability zones was like too much to do at once. Okay, so pausing and I will see you in a minute. All right, we're all destroyed. And now I'm looking at it further and I see that my AWS instance that I'm saying is my private instance, I'm seeing that I have a name saying coding with Kali public EC2, which makes me curious if that is the issue. When you have an issue and you're like, the computer's wrong. The computer's probably not wrong. It's probably you. All right, so I'm going to click Terraform apply, and then I'm going to click no, because you can see I also have another typo where I said I want the public security group and I actually want the private security group. So we have private instance, that AMI is fine, instance type is fine. Subnet would be the private subnet ID. We do not want an IP address that's public. We want it to be in the private security group, and we want it to be named private. All right, so now let's try to apply and let's see if it will actually work. And I'm going to say yes. All right, and they're all done. So let's go to my instances. I am going to go ahead and just look at running. And now I'm curious to test out this initialization thing. So public EC2 has a public IP address. If you look at the security group. Oh, interesting. So it looks like we do have to name the security group in order to have a good name, but we want it to be able to SSH from there. And then we want it to be able to inbound from anywhere. And outbound rules anywhere. Okay, so let's go to connect, and then we're to do the chmod because we should have a new key. And then let's do our SSH command. And awesome. So we can get into our public IP address. All right, now let's verify that we cannot get into our private. Okay, and these are still initializing, so that ready check 2 out of 2 does not need to be done in order for you to SSH. All right, so no public IP address, that's good. Let's go to networking. We're in the private subnet. Security group, we want to be able to have inbound traffic on port 80 from our public subnet. All right, so let's go to connect, and let's do our SSH command. And you can see it's thinking and thinking, which means that ultimately it will time out. All right, so this is pretty good. We're very close. We still have a few more pieces to the puzzle before you can actually use your Bastion host to SSH into your private host and actually get your NGINX images or your NGINX servers up and running and configured. All right. So I will see you in the next video. Now that we have our public and private instances, we can set up our Bastion host. So that way we can SSH into the Bastion host, and then from there, SSH into our private instance. All right, so I am going to copy my public instance because the Bastion host is going to be most similar to that. All right, and then I am going to try to slowly edit this so I don't make any mistakes. So I'm going to say AWS instance Bastion host. I'm going to leave the AMI instance type, subnet ID. It's going to go in the public subnet. We do want a public IP address with it. We'll use the same key, and then we need a security group. All right. So then we are going to we're going to say CWC Bastion host. All right. And yeah, I kind of want to add it with EC2. Okay, so now we need to have a security group because we don't want to just use the public security group. So let's go ahead and we'll copy the private security group here. And we will put it right on top of our Bastion host. All right, so security group, we're going to have coding with Kali, Bastion, host, security group. All right, so now let's think about what we want. So first I'm going to do, I think, name. I'm going to say that because I want to make sure I can see the names of all my security groups. And I'm going to add that for the private and public security group, so it's easier to navigate. Perfect. All right, now let's take a look at what we want. All right, so we want to allow SSH traffic. No, we want to allow SSH traffic from my IP address. And then we want to allow all outbound traffic. All right. So we want to allow SSH, but instead of all, we want to allow it from this CIDR block. So we'll paste that in there. All right. Next, we don't need traffic from port 80 because we're not actually using the Bastion host for any application traffic. So we can get rid of that. And egress, we want to allow traffic to go out to wherever. All right, perfect. Next then, we want to go back up to our private security group, and we want to change this CIDR block to being our AWS security group coding with Kali Bastion host security group .id. All right, now let's try Terraform apply and see what we messed up. Which wouldn't it be cool if it was nothing? Doubtful though. All right, so it looks like we are replacing the public security group, the private security group, and we're creating the Bastion host security group. We're updating our public instance and private instance in place, and we're creating our Bastion host. All right, I approve these changes, and let's go. And then I'm going to get rid of this comment because we already did that. And I'm going to review my Bastion host security group and my Bastion host instance. And I'm making the security group the public security group. So we want to make this the Bastion host security group. All right, and we'll have to go ahead and fix that once these are done. So I'm going to pause and I'm going to apply again with this change, and then I'll pick right back up where we left off. Just wanted to check in with you. I know you haven't been waiting because I paused the video, but it is taking a long time to delete. So if you are following along with me exactly, don't get super freaked out if it's taking 4 minutes plus to destroy your security groups and bring them back up. I'll go back on pause, and you know what? If it is something to be concerned about, we'll fix it anyway. All right, see you in another few minutes, although it won't be a few minutes for you because I'm pausing. All right, turns out it probably was a problem. So I waited quite a while for deletion. I waited 8 minutes and 20 seconds. Now, it could have continued working, but I don't think it would because the security group doesn't feel too big. And then if you look, you can say that we have a dependency violation, that we have a dependent object, okay? And it looks like we have that for both security groups. Execution halted. So I'm going to, then I went and looked into my security groups here, and I was like, let's go ahead and let's just delete them. But you can see we have an issue because they're referenced by other security groups or they're associated with instances or network interfaces. So they're definitely associated with instances. So what I'm going to do is I'm going to do Terraform destroy and just destroy everything, and then we can restart and go from there. So hopefully this is quite a bit quicker. But yeah, this is a good way to see if something's not working with Terraform. You can always go in and take a look on the console and try to figure out what's happening there. And we are now deleting. I will update you when we get applied once again. All right, so I got it all destroyed, went to apply, and I have that my security group is an invalid CIDR address, which Fair. I was kind of guessing that that was just magically going to work. So let's go ahead and use Copilot to explain this error and see if A, it explains it well enough that we know how to fix it, or B, it gives us some terms that we can then search and do some research on. All right, so if you're trying to allow traffic from all instances associated with a specific security group, you should use source security group ID or security groups, not a CIDR block argument. Fair, because it's not a CIDR block. All right, so let's go to our private EC2 security group here, and it's not going to be and we can do security groups and try that. All right. And now let's try Terraform apply. And let's say yes. I think we're getting close. And let's go to our EC2 dashboard. So we're creating our private instance here. All right. Looks like we have our public, private, and bastion host. All right. So let's just run through it real quick and make sure that we can connect. I'm going to go ahead and run the chmod just in case, because I did completely destroy all my resources, and then connect. All right, so we're able to connect to our public. Let's make sure we're able to connect to our bastion host as well. So connect, and instead, I'm just going to copy this so we can use our -a tag. I'm going to say SSH-A and then put in our bastion host and permission. Permission denied. Interesting. Having to do with our public key. Oh, because I didn't save this public key in the keychain. So let's just do this here. And so we can enter into our bastion host. And so then let's do SSH add key to SSH agent. All right. So this is generating the key. Now we want to add it to our agent. So first we're saying eval. And the reason we're doing this is we're starting the SSH agent in the background. Okay. All right. So then let's open up this file. So we're going to go to the root and open up the config. And we don't have one. Oh. Well, interesting. Okay, so we opened it here. This is not what we want. Adding SSH key to SSH agent. So it looks like we can do SSH-add and then add keys .ssh/ and then my key name is CWC-key. WC-key. So I think this is the folder that we're in already. So -key-pem. Added. Okay, so now we should be able to do SSH-A and then the bastion host. Woohoo! And we're in it. So now let's go to our private and we go to connect and we're going to say SSH and then grab this. Yes, we want to connect. And we connected to our private instance. Woo! All right. So we should have a few more resources still to add. I know this is taking a while, but we're doing great and we're almost there. And then we can finally install some stuff. All right. See you in the next video. All right, we are so close to being done with this challenge. All right, we still have a few more resources that we need to create. So if you look at our main.tf file, you can see that we have a public route table, and then the public route table is associated with a subnet, and we have an internet gateway that allows all of these pieces to connect, right? So that is why we are able to connect to and make requests to the internet and have the internet make requests to our public EC2 instance, all right? But if you remember in the first challenge, we also needed a gateway so that way the private instance can still download and install and communicate, like contact the internet in order to load our application on it. All right, so we need to set up a NAT gateway for that. All right, so what I'm going to do is I'm going to go to Terraform NAT gateway, and I'm going to look at how we do it. And if you look, you can see this example here for a public NAT, which is what we want because we want to be able to have our private instance communicate with the internet. All right, so we want this here. So I'm going to copy it over and I'm going to put it right under my public subnet information. All right, so now you can see that we have AWS NAT gateway, and then we are going to call it gateway NAT. All right, you can see then it's referencing two other resources. It's referencing a subnet ID, all right, which we need. So we're going to say AWS underscore subnet dot, and then we could either choose the public or the private. Now, ultimately, the NAT gateway is opening up a one-way gate to the internet, so we want it to be in our public subnet. All right, then we need to write .id. All right, because we're looking for the subnet ID. So now you can see that the white goes away, which means we have this resource. All right, I'm going to change the name of it to Coding with Callie NAT Gateway. Let me see what I named the, yeah. Sure, we'll do it like that. So now we have that part. That's good. We still need to figure out what this allocation ID is. So let's go ahead and scroll down to try to figure out what's going on. Oh, okay. So the allocation ID is going to be the ID of the elastic IP address, which is required to connect publicly. All right. So we are trying to connect publicly. So, and because that's what connectivity type defaults to, you can see we don't have the property for connectivity type. So it's defaulting to private and we want it to be private. So we need to create an elastic IP address. All right. The last part of this is that we want to ensure proper ordering. So we want the internet gateway to be created first and then the NAT gateway, because the NAT gateway is ultimately going to use the internet gateway to get out. Okay. So it's going to depend on AWS underscore internet gateway dot gateway. All right. And then I'm going to get rid of those comments. All right, so we are close, but this we do not have. So we have to create it. So I am going to go to elastic IP address AWS. And I'm going to try to look. So AWS EIP Terraform. Here we go. All right. A single elastic IP associated with an instance. All right, so we don't want it associated with an instance. All right, so this is creating a VPC, an internet gateway, a subnet, an EC2 instance, and then an elastic IP address. So we can add that it's dependent on the internet gateway. That's fine. Domain. Not really sure what the domain line is for. And we don't need those. So I'm curious if all we need is, okay, domain indicates if this EIP is for use in VPC. Instance is optional. Okay, Boolean if EIP is in VPC or not. Use domain instead. Defaults to true. All right, so we don't need to actually use domain or VPC because the default is true. So it looks like the only thing that we really need to include then, so I'm gonna put that down, and then I'm gonna say resource. Sure, we can add it even though it defaults it to it. And what do we need to do? We need to have a depends on, and it's gonna depend on our internet gateway. All right. I don't see any tags here. Okay, so it looks like tags is an optional thing. I'm not going to worry about it. And I'm going to, see how that works. And then now let's change this from example to, we are going to change it to, what do we want to call it? NAT. That works. All right. So then instead of AWS underscore EIP dot example, we're going to have .NAT ID. And hopefully this sets up our NAT gateway. All right, but as we talked about before, we still need to do the public route table and the route table association, or the private route table and the private route table association. So I'm going to go ahead and copy that and paste it down here and hope I don't get this wrong as I'm going through it. So I'm going to go line by line. All right, so we want to create an AWS route table. We're going to call it the private route table. It will be in this VPC. And what route do we need? So CIDR block. So this is going to be all. And then gateway ID is going to not be our internet gateway. Our gateway ID is going to be our NAT. I'm going to try to type it out to make sure I can remember this. .gateway underscore NAT .id. Okay, so that's going to be our gateway ID. So that's the route that we want. We want the NAT gateway to be able to communicate with the internet on all IP addresses. All right, and then we have our tags, and we're going to switch this from public route table to private route table. Perfect. The next one's our route table association. So we want to associate our private route table. We want to create our private subnet association. So the subnet ID is going to be the private subnet ID. And then the route table ID is going to be the private route table ID. All right. And hopefully this is everything that we need to add. So I'm going to go ahead and do Terraform apply and see how we do. All right, so we're going to add 4, which makes sense because we made 4 things. We made the private subnet association, the private route table, the NAT gateway, and the elastic IP address for the NAT gateway. I'm going to say yes. I probably could have been better by scrolling through and actually verifying that it was saying the right things, but might as well chance it. All right, it's creating. All right, so while we wait for that, we're going to go over to our instances. We're going to go to our Bastion host, and we're going to go to connect. And I'm going to copy my EC2 user here. So I'm going to get ready because I'm going to SSH into my EC2 user. And then I'm going to try to SSH into my what's it called? My private instance. I also forgot my SSH command already. So I remember though this, and I'm going to bookmark it now. And so now I know I can add it like with just SSH add. So the gateway is taking a little while, so I'll go ahead and pause and then I'll start back up when we're ready. All right, yay! Our resources are created. So now I'm going to do SSH dash add, and then I think it's coding with Kali key.pem. All right, warning, unprotected private file. My permissions are too open. All right, I will need to look into that at some point, but just make sure while you're playing around with this, it's probably not the best idea to go ahead and commit all of this to GitHub. So make sure you're doing adding a get ignore file and ignoring things like your Terraform, all of your state, your lock, your PEM key, your state, and your backup. So that way you are not committing any sensitive data. Okay. So then the next thing that we're going to do is SSH into the Bastion host, which I did not. All right, so we need to do our chmod first because it's a new key. And then we need SSH-A anyway. Nope, SSH-A. And then I need to recopy and paste it in. Permission denied. All right, let's take a look. Bastion host. We have a public IP address. We're using the public subnet. Let's look at our security. That should work. Let's go ahead and let's connect with just the normal SSH command. All right, so that works. So our SSH add seems to be the issue. So let's look at this SSH add, and then we want to add coding with Kali -key.pem. Couldn't open a connection to your authentication agent. So let's go ahead and check if our authentication agent is running. This really goes to show you too how important it is to okay, so we're getting different error messages, so that's something. No file. Oh, because I'm in my user. This is so silly. Okay. All right, so I'm in there. Okay, but if I do now, let me. Okay, so then SSH-add coding with Kali-p.pem. Okay, identity added. So then we want to do SSH-A and then paste in not that. And let's go back and get the correct address that we're SSHing into. All right, so now we're SSHing into the Bastion host and we're forwarding. So that way we should be able to now hopefully SSH into our private EC2 instance, which we were able to do before, but we weren't able to download anything once we did it. All right, so now let's go ahead and we want to install NGINX. Let me see if I can just remember the commands. So I'm going to say sudo yum install NGINX. Are we doing it? Are we connecting to the internet? I hope. Oh, yay! And we were able to install NGINX. So I'm going to go ahead and click that yes, that is okay. And this shows you that the NAT gateway works as intended. So I'm going to end the video here. And in the next one, we're going to get our NGINX installed. See you in the next one. All right, so technically you already know how to do this. We did it last week in the first challenge. All right, so I would challenge you to try to do this yourself. Here's the thing though. I haven't actually tested this Terraform yet. I haven't made sure that everything works as intended. Yes, I can SSH into things and I can forward traffic, or I can like SSH into my private instance from my Bastion host. However, I'm not sure that installing everything and doing my traffic forwarding, everything's going to work nicely. So I'm going to keep going. You can watch these videos. You can just try it yourself and then catch up later if it turns out you need to debug something. But anywho, we have our NGINX installed on our private instance. I was exploring some of the files, so that's why I'm in the wrong folder. But if you see, now we're in the root directory. All right, so we are going to cd into /user without the e /share/nginx/html. And then we're going to look at this index.html file. All right, so I'm going to type in sudo, so that way I can actually edit it, nano, and then index.html. And now I should be able to edit my file. I can say something like, yay me. And then maybe something like, I love to deploy stuff. And then, I don't know, maybe we want to get fancy. I'm going to say something like, you can do it too. All right. I'm kind of done now. All right. So then I'm going to go ahead and just delete the rest of this. And I'm too lazy to look up how to do this faster than just holding my backspace key. But if you look it up, please let me know, because that would be helpful information so I can do things quicker and be less lazy. All right. So now that we have that, we are going to save it. All right. And then we should be able to say curl localhost. We should not, because we didn't start it. So we should be able to say sudo systemctl start NGINX, and then we should be able to say curl local host, and yay me pops up. All right, so I can get out of my private instance now, back in my Bastion host. Let's go ahead and curl that private instance, because they should be able to communicate with each other through the default table, and we see the yay me, so that works. All right, now let's go ahead and we need to set up the proxy so that way we can forward traffic from our public to our private. So I'm going to go ahead and SSH into it. Okay. And then now this time we need to edit the configuration. So I am going to cd into /etc/nginx. And then let's take a look at where we're at. And we have conf-d. Also, side note, let me check NGINX version. I was playing around with this, so I'm pretty sure that I already installed sudo nginx-v. All right, so let me do sudo yum install nginx, because I don't remember if I installed it. All right, now I did. So now I'm going to go ahead and clear, and then ls. All right, now we have more files. Okay, so I'm going to take a look at this conf-d, and I don't see anything. I'm going to take a look at the nginx.conf. All right. Trying to figure out which file I'm editing, and I don't really want to look up the docs. So that looks pretty good, so I'm going to try it. So I'm going to say sudo nano nginx.conf. All right. And let's go down to our server block. And we are going to add location / because whenever we hit that index path, we then want to do the proxy pass. And we want to go to http:// and then we want to go to our private IP address, which is right here. And then we're going to do our semicolon, and that, hopefully, my friends, is what we need to do. So I'm going to exit out and save. All right, so now I should be able to do curl local host, and I couldn't connect because I didn't start it. So sudo systemctl start nginx. All right, now I should be able to curl localhost, and I see my yay me, which means that we are redirecting appropriately. So I should be able to then go to my public EC2 instance, my public IP address. I should be able to paste it in up here. And hopefully, we see my yay me. I love to deploy stuff. You can do it too. All right, and that concludes this challenge. I'll see you next week.